Hello students, this video lesson is about adding and subtracting integers. Integers are a category of the real number system. Integers are made up of the whole numbers and their opposites. Whole numbers are 0, 1, 2, 3, 4, and so forth, and their opposites are the negative counterparts. The positive numbers go in the right direction on a number line, and the negative numbers go to the left on a number line. When we're talking about adding integers, the first thing we consider is whether or not the integers have the same sign. For instance, a positive 6 plus a positive 5 is going to give us a positive 11. A negative 7 plus a negative 10 is going to get us or give us a negative 17. So if they have the same sign, we're just going to add them together just like they were whole numbers and give them the sign that the numbers have. Another way of looking at integers is money. When you add or deposit money to an account, the balance goes up. If you write more than one check or any check, you spend or take away or overdraw from an account that has no money in it, you increase the negative balance of that account. So an example of this would be, say, if an account has $50 in it and a person deposits $25, the total value in the account would be $75. I can represent this with integers. I could say $50 plus the 25 is going to equal $75. Another way to represent integers with money would be, say, a person has an overdrawn bank account of $40, and that person writes a check for $10. The person now has an overdrawn account of $50, or in other words, that person has a negative $50 balance in their account. So when you overdrawn, that means you're in the hole. You owe the bank money. So if it was overdrawn by $40, that would be a negative 40. And if I added another negative value, which is the act of writing a check, so that would be a negative 10. And I added those two together, that's going to give me a negative 50. Another way to look at adding integers is with a number line. The number line, positive numbers go to the right, negative numbers go to the left. So if I start at 0, and if I add negative 2, I'm going 2 units to the left. But then if I'm adding a negative 4 to that negative 2, that means I'm going 4 more units to the left, which makes me end up at negative 6. So let's say I have 3. So I start at 0 and I go 3 units to the right because 3 is a positive number, and I add to that 2 more positives, which is going to take me to 5 on the number line. So we can always think of adding integers on a number line. If it's a positive number, I'm just moving further right. If it's a negative number, I'm just moving further left. Now the absolute value view of adding integers is very similar to the number line. The only thing that's different is that absolute value is representing the distance. So instead of just going further left, the negative sign of the number does tell you what direction it's going, but the amount of distance to the left is figured by the absolute value. So 2 plus 3 would be the absolute value of 2, which is 2, plus the absolute value of 3, which is 3, going to the right. So that's going to give you a positive 5. Whereas if I had a negative 4 plus a negative 3, or negative 3 plus negative 4, I took the absolute value of each of those numbers. The absolute value of negative 3 is 3, but since it's negative, it's 3 units to the left, plus the absolute value of negative 4, which is 4, but it's also to the left. I have a total of 7 units to the left, and since it's to the left, it gets a negative value. So those are 3 separate different ways of thinking about adding integers. I'd like for you to go ahead and stop the video and try these 4 practice problems out. Try to add these integers without a calculator. Your mind is so much faster than a calculator. And later on, you'll have really large numbers that calculators will be great for, but you don't want to slow yourself down by adding and subtracting integers. So how did you do? Let's go ahead and compare your answers with the results. -5 plus -9 is going to be -14. 14 plus 8 is 22. 17 plus 12 is 29. And -36 plus -27 is -63. When you have two-digit numbers, it's good to set them on top of each other, where you add the ones position and then you add the tens. This makes it much easier. Our next aspect of adding integers that we need to consider is when they have different signs. When integers have different signs and you're adding them, you're really subtracting them to get the answer. What you have to do, or at least what I like to do, is I like to consider what I have more of. Do I have more negatives or do I have more positives? So after I've determined what I have more of, I subtract the numbers and I give it the sign that of what I had more of. So -5 plus 4 equals -1. Well, I have more negatives than I do positives. So I take the 5 minus the 4 and I get 1. And since the 5's original sign was negative, that 1 also gets the negative sign with it. Another example would be 9 plus -3. They're different signs, so I'm really going to have to subtract. I have more positives than I do negatives, so I know my answer is going to be positive, and I simply take the 9 minus the 3, which gives me 6. The different signs, you're really subtracting. Whatever you have more of, that is the sign that the answer will be. Again, you can think of money. If I wrote a check for $50, but only had $20 in my account, I would have a negative bank balance of $30. Or in other words, I would be overdrawn by $30 or a negative $30 balance. An equation with integers would be -50 plus 20 equals -30. Another example with money is if I had an overdrawn account to begin with of $80 and I deposited $100, I would have a balance of 20. So as an equation with integers, I would have -80 plus 100 equals 20. They're different signs, so I really subtract. I take the 100 minus the 80, I get my 20, and since my 100 was positive, my answer is positive. We can utilize a number line for subtracting integers as well. Whenever you have a negative number, that just means you're going left. You always start at 0, and I have -7, so I'm going -7 or 7 units to the left. Now, I'm going to add 5 units, and it's a positive 5, so I'm going to go to the right 5. And that's going to take me to -2. Let's say I start with 4. So I'm going 4 units to the right. Too many. And then I'm going to go 3 units. What's that? So I'm going 4 units, 1, 2, 3, 4 to the right. And then I'm adding a -3. So that tells me I have to go back 3, 1, 2, 3. And it's going to take me to a positive 1. Okay, let's move on. When thinking about absolute value, simply determine the absolute value of each number, then subtract the smaller absolute value from the larger absolute value, and give the answer the sign of the number that had the larger absolute value. For instance, 6 plus -9. The absolute value of 6 is 6. The absolute value of -9 is 9. Well, 9 is the larger number, so 9 minus 6 is 3. But since the original number that the 9 came from was negative, the answer is going to be negative. Okay, I would like for you to stop the video and try out these problems, and then we'll compare our answers. So how did you do? -4 plus 13 gives me a positive 9 because I had more positives than I did negatives. Positive 9 plus negative 18 equals -9 because I had more negatives than I did positives. Different signs I subtracted. 24 plus -10, again, different signs, so I subtract, but I have more positives, so my answer is going to be positive 14. -14 plus 12, different signs, so I subtract. I have more negatives, so my answer is negative. Now, subtraction of integers is just a little bit different, but not much, because we're going to change it to an addition problem. All subtraction of integers can be changed to addition problems. What you simply do is you take the first number exactly the same. So keep the first integer just as it is. Then you go to the minus sign and you change the minus to a plus. And then you go to the number on the right of the minus and you change it to its opposite. If it's a negative number, it becomes a positive number. If it's a positive number, it becomes a negative number. And then you go back and you utilize one of your addition rules. So positive 9 minus a -3, the 9 stays the same, the minus becomes a plus, and then the -3 becomes a positive 3. Now I just have 9 plus 3, which gives me 12. -10 minus 4, well, the -10 stays the same, the minus becomes a plus, the positive 4 becomes a -4. Now I have two integers that have the same sign, they're both negative, I just add them together and get more negatives. -10 plus -4 gives me -14. -8 minus a -6. The -8 stays the same, the minus becomes a plus, and the -6 becomes a positive 6. Different signs, so now I have to subtract. I have more negatives, so my answer is going to be negative. 8 minus 6 is 2, and since 8's original sign was negative, the answer is -2. -7 minus 10. Well, the -7 stays the same, the minus becomes a plus, and the positive 10 becomes a -10. Now I have two integers with the same sign. I just add them and keep the sign. -7 plus -10 becomes -17. Note when you have two negatives right next to each other, separated by a parenthesis, the operation sign changes to a plus. 7 minus a -3 becomes 7 plus 3. -9 minus -2 becomes -9 plus 2. One student told me that they just like to hook the two negatives together and put a plus there. But this particular rule is not true if you're using absolute value bars, only with parentheses. If I have a negative absolute value of -3, this means the opposite of the absolute value of -3. I can't hook those. The absolute value bar is like a wall. I can't just take the one negative and hook it with the other negatives, make it a plus. That just won't work. It can't cross that wall. The absolute value of -3 is 3, and then the opposite of 3 is -3. So if I have 7 minus the absolute value of -6, that really becomes 7 minus 6, because the absolute value of -6 is 6. Now I can subtract those, and that becomes 7 minus 6, which is 1. -10 minus the absolute value of -2 becomes -10 minus 2. If I want to change the opposite, I could say -10 plus a -2. Same signs, more negatives, I get -12. Here's some other examples. 5 minus -4 minus the absolute value of -8. That becomes 5 plus 4 minus 8, which then becomes 9 plus -8, different signs, so I subtract, more positives, so my answer is +1. The other example is -5 minus the absolute value of 2 minus a -4. Well, the -5 comes down. The absolute value of 2 is 2, so I just still keep my -2 there. And then I have a negative with a parenthesis with another negative. That becomes a positive. So the -5 minus 2 I can rewrite as an addition problem. -5 plus -2, which gives me -7. Now I bring down the 4. I have -7 plus 4, different signs. So I really subtract, and I get a -3. Okay, it's time for you to practice some. Go ahead and write these down. Stop the video, write them down, and give them a try. So how'd you do? Move this. 5 minus 12 becomes 5 plus -12. Different signs, more negatives. My answer is negative. 12 minus 5 is 7, so -7. -8 minus a -5, there's a minus with the next parenthesis and a minus, becomes a plus. So -8 plus 5, different signs, so you subtract, more negatives, so your answer is -3. -7 minus 8 becomes -7 plus -8, same signs, just add them together, give them the same sign, -15. 7 minus a -7, which becomes 7 plus 7, same signs, just add them together, and you get a +14. Okay, now you have reached your discussion board problems. You have 3 problems from 3.1, and you have 3 problems from 1.4, so 1.3 and 1.4. So go ahead and write these down, complete them, take a photo image or scanned image and upload to the discussion forum. If you have any questions, just email me.